Okay, students, we are back. And let's see how we did. Let's see what our residual plot looks like. For 9, you're going to do the same thing we had just done in 8, only we're going to plug in 8 hours in for time. So I've set up my equation here. I want to find the number of bacteria. I need to do 1.4 times e to the power of 0.233 times 8. And what you should get out of that is 9.03. Okay, let's get the residual. The residual is going to be our actual value at 8. So our actual value at 8 is 9.5 minus our predicted value of 9.03 that we just got from our equation, so that you should get a residual of 0.47. Okay, I'm just going to plug all this stuff into this table here. 3.56 was our prediction there, with a residual of 0.14. 9.03 was our prediction here, with a residual of 0.47. And now let's create our residual plot. Remember, we have 1 here and 9 here. I know the formatting's a little strange, but let's make this plot. Okay. At time of 1 hours, we have a residual of 0.03. So that should be like very close to 0 right there. And then we go down to negative 0.13, negative 0.8, .14, negative 0.29, positive 0.33, negative 0.35, .47, and then negative 0.2. Okay. It says, based on this residual plot, is this exponential model a better fit than the linear model from the last page? We're going to say, yes, it is. Most definitely. Even though some of you might be like, well, isn't there kind of like a diverging pattern? Maybe, if you really looked at it hard. But overall, when I'm looking at this residual plot, this is way more randomly scattered than this one. In this one, we have this clear U-shaped pattern. In this one, it's like, it kind of looks basically random scattered. We have some points above the line. We have some points below the line. It's a lot better. So we're just going to say, yes, this residual plot is more randomly scattered than the last. Therefore, the exponential model is a better fit than the linear model. Yay. And that's all we're being asked to choose between. We're not saying, is this model perfect? Is this residual plot perfect? We're just being asked, which model is better between these two options? And definitely the exponential one is better. Okay. Hopefully, you also now have this last page. This is the last page of notes we're going to do today. So hopefully while you were watching that first part of this video, you've obtained this next piece of paper. If not, go ahead and pause this video for a moment until everyone has a copy. But at the top of this next page, it says residual plots are a great way to help choose the best model. But it's not the only way. So that's kind of our topic for today is, how do I choose the best model? When I'm looking at a set of data and I'm trying to decide, is this exponential model better? Is this linear model better? How do I choose? Residual plots are one way, but it's not the only way. Another method is to calculate the sum of the squared residuals for both models. Okay, the sum of the squared residuals is something we've seen before. Back in when we were looking at all that animal data. Okay, so let's draw some stuff on this graph here. Here we have that same time versus number of bacteria data. And here we're back to having our linear model here. So I just want to remind you about what the sum of the squared residuals is. So we're going to mark up this diagram a little bit. So we're going to use arrows to represent the residuals. So I'm going to go through and I'm going to draw in the residuals for each of these little points. Some are going to be almost a little bit too small to even fit my little arrow in there. Okay, so we've drawn all the residuals in. One thing we learned when we looked at that animal data and also in a couple of other lessons is that, well, some residuals are positive and some residuals are negative. This would be a positive residual. This would be a negative one. This would be a positive residual. This would be a negative one. And it's nice. We'd like to know what's the overall amount of error across the entire model. But we can't simply add these residuals together because all the positives would cancel out with all the negatives and we'd be left with like a useless number. So what's our solution for that problem? Well, what we do is we square the residuals. So we take all of those individual residuals and we square them so that we can kind of visualize all these squares like this. And hopefully this is coming back to you a little bit because you've seen this before with all that animal data. You've seen these squares before. Okay? Points farther away from the line have a much bigger square. Points close to the line have these smaller squares. But this is how we can kind of think about all those square residuals. So what I'm doing when I find the sum of the square residuals is I'm taking all these square residuals and I'm adding them up to give me a single number that helps me understand how much total error there is across the entire model. So, by the way, I'm going to abbreviate some of the square residuals as SSR. Otherwise, I'm going to drive myself crazy writing that over and over again because we're going to write it a couple times in our conclusions. Okay, so here's what we're going to do on this page. We're going to calculate the sum of the square residuals for our linear model and for our exponential model, and we're going to use it as a second way to verify that the exponential model is indeed the better model. So how do we do this? Well, I've brought all of the data down. We still have our x variable, our y variable, our prediction, our residual, and then we have a new column in this table that says the square residual, where literally we're just going to take the residual and square it. Okay, so for instance, how did I get 1.21 here? I just took the residual, which was 1.10, and I squared it. Let's do the next one. Let's find the square residual for 0.23. Okay, I'm just going to square it. And for that, I'm going to get 0.053. Okay, I'm going to turn it over to you. I want you to find the rest of these squared residuals. These blanks here, you can fill in with the stuff that you've already found in prior pages. Then I want you to find all of these square residuals. And then for both, at the very end here, you're going to take all of the square residuals that you found and add them all up to get the total sum of square residuals. And then you'll respond to these last two questions based on what you get. All right, I'll see you on the other side.